So, hi everyone, how are we doing? It's late on the last day. Everyone's tired. Should we have a really deeply technical talk? Will that kill everybody off today? It's not going to be deeply technical. We're going to do an overview of console development in Unity. So thanks to all of you for making the graveyard shift today. That's great. So for all of you in the room, let's just have a quick hands up. How many of you have made a game in Unity and shipped it? All right, that's most of you. That's good. And of you who have done that, how many of you have developed a game for console? Nice. And how many of you have developed a game targeting multiple platforms at the same time? Okay, so a fair few number of you. Okay, good. So what we're going to go through today, I'll give an overview of what I'll be talking about. Let me stop my timer. We are going to be talking today about the platform holders, the process of registering with platform holders and getting access to development hardware and software, which by the looks of it, many of you have already done, but a few of you haven't. We'll be looking at your development environment, talking about setting that up for console development, some best practices when it comes to console development and some good tips to help you succeed. Submission and certification is an area that often catches a lot of people out if they're not aware of that process. So we'll talk through a few things to help you get ready for that. And we're going to have an open QA about your experiences and any questions you want to ask me. I may not be able to answer all of them, especially if you are Uber engineers, because I am not an Uber engineer. Who am I? I work for Unity. I am a senior technical product manager in consoles, research and development. So my role is that of looking to the future of console development in Unity and how that works and what the experience has been like for our developers and what we all need in the future. I'm also an indie developer and I make games on PC and console. I've developed a couple of games. I'm not going to say that my games are amazing or wildly successful, but I'm pretty proud of them. But I've been through the same process that all of you here have been through. And I was an indie developer before I joined Unity. So when I joined Unity, I also had a fair, varying versus love versus, not so much love for the process of bringing games to multiple platforms in Unity, which helps inform me even today what I do. So let's talk about the platform holders. One thing that I will say is we're going to focus on consoles here, and there's only so much detail I can go into for reasons who any of you who have been through this process before know that we have to sign certain things as a non-disclosure agreement. So I can only talk about things here today which are public domain. We have Xbox. So if you want to register with Xbox, you can go through the ID at Xbox program. If you don't know what that is, you can go to ID. You can go to xbox.com/ID, and there's more information at the developer portal there. ID at Xbox is there to help you get into development on the Xbox consoles with Unity, and you'll be provided hardware and resources to do that. At Sony, you have partners.playstation.net. You can register to be a Sony developer there. And you also have Nintendo at the developer.nintendo.com. The submission requirements for each console are there. When you register, I would suggest you give their documentation, and the portal's a good read. Just be aware that they require you to sign non-disclosure agreements. This is why it's really hard to find information sometimes about console development in Unity or on any engine, actually, because a lot of it is locked behind NDAs. So you will have to sign those NDAs to gain access to the resources needed to find out what you need to do to make games in Unity. So I'll try and demystify some of it for you today. In order to get access to development hardware, this can be purchased directly through the programs, or in some cases you'll be given hardware through some of those programs as well. You will need a non-public email address, so not a Gmail or a Hotmail, and in some cases you will need to be a registered company within the territory that you work in order to gain access to these pieces of hardware. So your development environment is the next piece that you'll need to do. And when we come to setting up your development environment, there are specific hardware requirements that you might not be aware of. You need a Windows 10 PC. Yes, Unity runs on Linux and Mac, but you cannot develop for console on Linux or Mac. You must use Windows 10. You will need a dev kit, and hopefully you will have procured one of those through the program that you're working on. I would highly suggest that you set up some kind of KVM or second monitor. You can work off one screen if you want, but I wouldn't wish that on anybody who is attempting to code, develop, and deploy and test on a single screen. So setting up your environment ready to deploy is necessary. Your software, you're going to need to choose a version of Unity, and that version is important. If any of you know the different versions of Unity, I would highly suggest that you stick to the latest LTS, or long-term support version of Unity. That is the most stable version of Unity that is fully featured and is fully supported by all hardware platforms. You can use the text stream if you are chasing new features, but bearing in mind that text stream is not what we would consider to be fully stable. That's your LTS versions. And if you are in serious development, you're porting over a game, you might want to consider having stability as your friend whilst you're moving through that process. You will need Visual Studio. You will need Unity and its various console extensions. You will also need to download the platform-specific SDKs for every platform that exist. And those versions, in some cases, need to be paired. So, for example, a certain SDK might need a certain version of Unity, which also needs a certain version of Visual Studio, and thus opens up the world of having to manage multiple installations of various different things if you're using one computer to develop for all the platforms that are available. There are also specific network and IP requirements. In some cases, you're required to have a static IP address. That can be a bit of a pain if you're not working at an office that has a static IP. Certainly for Sony, you will require that. So I would suggest that you find some way to get yourself that. You can subscribe to a VPN service or buy a static IP that you can route through. It is a pain, but it is there and it needs to be done. You won't be able to develop without one. And ideally, dev kits need to be connected via a physical switch, not via wireless. It's recommended that you connect everything together on a physical wired network to make this process work as well as it can. So some best practices around development now that you've got your environment set up. Know your hardware. One thing that is really important is you need to understand the device capabilities of the actual machine that you're targeting. What works fine on PC is not likely going to work well, or as well as you expect it to on console. And that's especially true of Switch or last generation. I'm sure a lot of you have probably got really nice gaming PCs that you might develop on as well. You know, your Threadripper with a 3090 is not necessarily, gonna have the same horsepower required, of an Xbox One. You do have different memory, GPU and CPU speeds that you need to contend with. Also, you've got different control schemes, haptics, all those kind of things. And, you've got things like file sizes and other things that you need to worry about, I/O. Your development, when you're doing this, so you really need to look at the target device that you're looking at. And that's where the various tools for the platforms come into play, understanding how much memory you have available. For example, a Switch has 4 gigabytes, but an Xbox One X has 12. So knowing what your memory footprint of your game is and what your GPU, the amount you're using on your GPU while you're building games is especially important. And we're going to touch on profiling and optimization later on. You also have asset limitations. This is another area where, your 8K skybox that you have probably looks fantastic until you try and run it maybe on a Switch. You might want to think about the amount of polys in your geometry and the texture sizes. And, especially when you're looking at the target resolution that you're looking to port your game to, is it necessary? And that includes things like video. The size of your video files, the compression that you use, what bit rate are you looking to throughput? Because obviously sometimes these devices cannot support the same bit rates that you would be putting out on your title if it was PC. One thing that we keep kind of come back to is build and test for your minimum spec. The amount of developers that I work with that only consider the minimum spec right at the end of development and then realize that you have developed yourself down a dark hole that is now going to be very difficult to get out of when your game is already complete. I would highly suggest that you have access to this hardware. Please start running your game as early as possible on your minimum spec device. And if that's going to be, for example, if you're targeting Xbox primarily, then make sure you're testing on Xbox One and not the Xbox One X hardware before you're ready to deploy. So when we come to preparing your project as well, now that you're moving into console development, think about your compatibility. There are a number of assets. If you use a lot of asset store products, not all of them will work on console hardware. So you need to make sure that you check the compatibility of any third-party plugins, any assets that you've imported, any code bases you've got. They might not function. I know a lot of people, for example, use plugin for input. Those plugins that are the very popular ones don't necessarily work on every piece of hardware. So do check that. But hopefully those plugins will be well documented for you. Your render pipeline is also an important choice. Check your render pipeline actually works on the target platform. I've seen a number of titles using HDRP that realize they can no longer port to Switch. Don't be in that position where you're having to rebuild all of your materials and your render pipeline from the ground up when you've already made a game. The built-in pipeline works across everything within Unity and is considered to be stable and mature. We have URP, which does work across every platform, but HDRP doesn't work across every platform. So be conscious of that and your shaders and other things that you might be using, custom SRPs, etc. And your build settings. Refer to the documentation about setting up any development sandboxes. So if you've never done this before, in order to build to the device, you need to have your sandboxes set up. So if you can imagine you've got console, have online features, such as Xbox and PlayStation, you're required to set up a sandbox test environment so that you can test those features, that you can log a user in, that a user can actually gain access to the game and be able to test it that way. So you need to set all of those up before you start development as well to ensure that you can build. Maybe try setting up an empty project and just importing the absolute necessary things that you need to import into it and seeing if you can build it to your target device and run it is a good test to make sure that your environment is set up and working correctly before you start importing code. So let's look at some development tips. Platform features. So here's a pretty big one. It's a big topic. Every platform has a number of features available to you, and you need to understand what all of those features are. In certain cases, those features are available, and in other cases, they're also required. You will fail certification if you do not use them. Unity does provide a set of plugins to interface with your platform-specific native APIs from C# scripts, and that makes it easy for you to add support for those features that are specific to consoles. Those plugins do come with documentation and source code. For example, I'm sure everyone's familiar with achievements, right? We use achievements in multiple platforms, and they pop up in the game, and in order to trigger that pop-up, you need to control how it's displayed, and you need to call the Xbox and PlayStation APIs directly through your native C# code to do that. However, that code needs to change every single platform. Right now, Unity does not have, and we are looking into that right now to look at how we can help developers move across platforms right now. But right now, you're going to need to code this independently. So we refer to this as platform abstraction. So I would suggest that if you're already embarking on a game and you want to bring it to console, this is the area that's probably going to save you the biggest amount of time if you start investing in it now. You are going to have to handle input, and you're going to have to handle user management. And that user management isn't just, for example, who am I logged in? But what if that user that's logged in logs out in the middle of your game? What if somebody logs in who doesn't have an entitlement to that game? Or, there's so many different, and that happens with controllers. Controllers can change order. They can disconnect when the battery goes flat. There are all of these kind of platform-specific features and functions that you need to look after. I would suggest that you start maybe looking at abstracting some of those into your own custom code so that you only call that code once and all you have to recode per platform is maybe you would write your own, I don't know, mygame.achievements that has a get and set. And then behind that per platform, you can just change that API layer interaction so that you don't have to recode that for every platform that you're targeting. Will save you time in the future. This is probably a bit obvious, but it's amazing how many people don't use source control. Like plastic SEM is available inside of Unity, and there are many other alternatives. Please, if you're doing multi-platform, you might want to consider source control to manage this for you so that you can easily change your branch per platform and merge your code bases. It will make life a lot easier. It's also a hell of a lot easier if you do this at the beginning, and again, not like towards the end of the project. It will dramatically reduce the overhead that you have during development. Yes, asset loading and management. So here's another thing that catches a lot of people out. If you've used Unity before and you've used something like resources, resources.load or resources folder, don't do that on a console. It's very bad. It will load everything into memory. Anything that you put into resources loads into memory immediately, and you will likely have horrendous launch times. And it's another way of failing certification in some cases as well. Start to look at the use of asset bundles if you're already using them, or maybe even consider moving to addressables. Those solutions are there to help you manage your asset loading and reduce down the amount you're loading in at any one given time to anything that is required on the fly. This will really help you on platforms that are quite restrictive in the way that they allow you to, with memory limitations or with patch sizes or with, patching is another thing. Like you do not want to, it doesn't look great if your game requires you to update a bug fix every other week as your users are finding it and they're downloading 27 gigabytes every time you're doing it on a Switch or something is not going to fend, is it? So start looking at asset bundles and these kind of solutions to help you through that, or addressables. The editor does not equal the console. And that's something that if you haven't done console development before can catch you out. We're used to building and testing our game in the editor, right? We play it in the editor. Whoa, this level's great. And then you realize that you're making a console game and it just won't launch anymore because you're dependent on the user being logged in, or you're dependent on having the hardware connected, like the controller. You can't simulate these. So the only option you've got is to build to the device, which is a good thing because you want to be testing on the device as regularly as you can, but you might also want to look at maybe making your game run in a way, either writing your own debugger, your own debug code or something. You can abstract out all of this stuff so that you developer tools, so you can disable all the platform features so you can actually test your game in editor. Otherwise, your iteration time for testing can be quite long because you'll be deploying to the hardware every time you want to test a change, which from an optimization point is probably great, but from a sanity perspective and actually getting a game finished in any space of time, you may want to look at that as well. Code limitations. Another thing is consoles require IL2 CPP. Okay, so only ahead of time compilation works. So beware of anything that's used in reflection and serialization and just-in-time compilation. So with IL2 CPP, if you've never heard of that phrase before, that's intermediate language to C++. With IL2 CPP, your C# code is compiled into intermediate language using the .NET compiler, which is the Roslyn compiler. And that Unity's IL2 CPP converter translates that IL output into native C++, which is in turn compiled using each platform's own C++ compiler into a native library that executes on the hardware. That's a statement. Which is great because it means that we turn your code into something that is nice and zippy and fast and runs in native on the CPU. However, that does come with a constraint because it means you can perform only ahead of time compilation. So if you are using things like special dynamic types or you're using reflection in your code, that probably will not execute on the console. So you just need to be aware of certain coding patterns when you're building to console as well. And then we have the big area, which is profiling optimization. Profile often and do it after any major change in your code base. You'd be surprised at what probably doesn't even register on a PC can have a massive impact on a console. Something that could execute in an nth of a millisecond might execute considerably slower on a console. So Keep your profiles. You can save your profile data, and it's a good way of being able to then look at what you did in version X that you published last time to version Y and compare that difference. See that new, wonderful, complex, deep AI you've just written for your game. How does it actually execute on the hardware when you come to look at it? If you want your game to run at 60 frames a second, if you've never profiled before, you really want to be looking at making sure that every frame is ready to go in a 60th of a second, which is about 17 milliseconds. I'm not getting into the absolute math, but lower than 17 milliseconds is good. Lower than 10 is fab, especially if you can do that on the lowest hardware, lowest common denominator platform that you have. So if you're bound by CPU, it could be due to your script code, disreads, UI layout rebuilds, physics. If you're bound by GPU, you need to pinpoint where you're being bound by. That's likely to come in the graphics pipeline bottlenecks, particles, post-processing effects. I know people do like to get Unity games, import post-processing, go, yeah, that looks great. And then you run it on Switch and like, ooh, that's not running so well. Look at how you're using your post-processing stack. That's a common cause, and the amount of particles that you're spawning, real-time lights, anything that's going to have heavy GPU compute. You can actually profile this with Unity's built-in tools. If you've used the profiler before, you can connect the profiler directly to hardware while it's running. So you can profile your game in real time. Each platform also provides its own profiling tools to look deep into the CPU and GPU frame by frame. If you really want to get deep into that, there's great tutorials online about how to use the profiling tools. Look at garbage collection as well. I was going to say, use your profiler to identify any CPU spikes that you might get. CPU spikes normally comes from garbage collection. If you're allocating a lot, try and find out where you're allocating, remove those allocations, start caching things. And if you really want to go deep, you can use the deep profiler or profile markers if you've ever used those before. Deep profiling is great. However, deep profiling takes a big old resource hit. So while you're deep profiling, you're going to be capturing an absolute ton of data. So just be aware that the game's not going to be running well while you're profiling, but it's a good way of being able to delve into absolutely which line of code in which script is causing these problems. Or you can use profile markers. If you've ever used profile markers before, they're a great way. You can put profile markers in your code. You can simply place a profiler.begin sample, and then you can sample whatever is in that code, and it will show in the profiler. Just remember to put an end sample somewhere after it as well. Yes, that's profiling on device and deep profiling. So I would say that this is the one area that catches most people out, is not profiling on the device hardware. It's easy. Just keep developing on PC and just expect a powerful console like an Xbox or a PlayStation to actually run that code well. More often than not, it does not. So start profiling often, figure out where those overheads are, and try and eliminate them through good optimization where you can. So let's assume that you've been through that process and you have made this amazing game. You've got to get it through submission and certification as well. Each platform is different, and each platform has requirements around reliability, performance, and behavior for the use of that platform. So, for example, the correct input handling and use of APIs, any events and UI, events like disconnections, reconnections, network disconnect, suspend states, user swapping, going back to the home screen. You have to handle all of that stuff in your game. You've got to handle saving and loading. And this is an area that catches a lot of people out as well, because we sometimes default to things like player prefs. If you're literally just saving, volumes on Mixer, or you're saving screen resolution settings or something, you can't use those functions anymore on a console. You will have to specifically call the hardware in order to access the storage. And in order to do that, you have to have a valid logged in user, because when you're logged in as me, all of my storage is associated to me. So you have to go through the process of calling that to get access to the storage, to write the data, to retrieve the data, to write it back. And if you don't use that, you will fail certification, because you can't write any other way. Understand those certification requirements really early does help. They don't often change, but they can do mid-cycle. So, for example, from the Xbox One to the Xbox One X, or the Xbox Series, sorry, get my terminology correctly, there was a change in the way that those features were handled, which required you to make some code changes if you were using a different SDK. So just being aware of these things beforehand and knowing when you're due to certify, try and get these things in really early. It will help along the development cycle if you integrate all of this. And write your own managers. I kind of mentioned that before. Try and abstract out achievements is a nice simple one, and rich presence if you're using it. Like some of the more simple ones are easy to abstract out so that you don't have to rewrite that code. That's not an exhaustive list. I mean, there is a lot more that you have to handle, but the majority of people just get hung up on these API calls and the performance around optimizing on the device. So, because I realize it is towards the end of the day and you do not wish to be bored to tears by somebody talking at you, I'd rather open the floor up to some questions, if anybody has them around this. I believe we have a microphone coming, so I'll let the mic wake its way around. I also appreciate I talk very quickly and get through slides very quickly. So if I have skipped over things, please let's refer back to them. It's fine.
Hi there. Hello. Hey.
Hello.
There he is. Cool. Thanks for the talk. Really useful. Brush up there for me, certainly. Quick question. How is the ECS and job system holding up on consoles at the moment? Can we use those, or are they subject to some of the limitations that you described?
So with the new dots system within Unity, our recommendation is that you only run anything that is in a verified state. Experimental packages are, by their very nature, experimental, and so therefore your mileage may vary depending on the platform that you're releasing on. But with jobs and with ECS and Burst, they should function absolutely fine on console platforms. But a lot of the dots ecosystem goes further than that. And a lot of those packages are still in experimental or in preview because those systems are not due for completion in our current cycle. So I would, again, test. Like, that is the best way you can do it. If you're making heavy use of dots in the project, then test it on the hardware ASAP, and you'll soon know if it's underlying that, if it's underpinning that much, you will soon know because you would spot a failure. But I don't see any reason why it wouldn't.
Hi, sorry. Yeah, we're quite deep Unity users. I really don't understand why this cross-platform stuff isn't a priority for your company. It's a really easy win. We are kind of reinventing the wheel every time we port anywhere. Why is achievements not in the system? Why are the controllers such a pain? Why aren't you handling the users? It should be the absolute number one priority in Unity. Nothing else should really matter.
I agree, which is why it'll be good to know that that's literally what I'm working on right now. It is my priority. I am attempting, well, not attempting, I am doing. I should choose my language carefully. So there is a survey up at the moment on every one of the Unity forums where there's a platform, you'll pretty much find it. I'm looking right now to find out what the pain points are. We make assumptions at Unity, right? I'm a developer. We have many people at Unity who make games. So we make the assumption that we probably know which areas you have to recode over and over again that are a real pain point, and again, and again. And it's not just even new games. You make a game that came out 4 years ago on a previous generation, you want to bring it to this generation, SDKs have changed, you now have to rewrite. So we at Unity are now saying, okay, so what could that look like if we were to solve that problem? And we believe the answer to that is a common API layer that will handle all of this for you so that you say, I don't know, I don't name APIs, but let's say it was Unity.achievements, right? Which is a terrible name, but we're going with it right now for these purposes. Unity.achievements.get, Unity.achievements.set, right? You write that once, maybe it works on every single platform that Unity provides, a platform to. That's the ideal, that's what I would like, and I'm trying to find out if that's what people want. Because we make that assumption that actually, if you're making a multi-platform game, this is what's likely to hurt you, right? Is user management, save and load, achievements, rich presence, notifications. I mean, actually, if you start to look at every area that any developer has to rewrite per platform, it's a really long list. And some of them, like when you start getting into cross-platform multiplayer, or any other, it's a big hole with which to go into. So what I'd like to do is to look at how do we solve, can we even solve it is a question. As you know, if you develop on a lot of platforms, when you start to look at how many platforms are out there, there's a lot of SDKs that you have to work with, and they change at regular cadences, and they're changing all the time. So how do we do that? So I would urge you to go, and if you are passionate about helping solve this, the survey is live now. You can fill in, if you want to put your details in the end of that survey, you can speak to me directly on this topic. I would love to engage with any of you who want Unity to solve this, because I believe it is one of our biggest priorities, which is why it's what I do at Unity now. Yeah, I hope that. I mean, I'm not saying we can solve it, but we should look into it, and that's what we're doing. And the role of product is to investigate that and speak to everybody who goes through it and figure out, is it the right way of doing it? Does anyone want to tell me about their experiences developing the console? Like, what was it like for you? Did you find it easy? Was it tough? What kind of hurdles did you hit?
Yeah, we developed a PSVR game a few years ago, early days of the system. I'd say the SDKs that we were working with the PlayStation team with Unity, and yeah, they were great. Really top support from the guys on the forums, solving lots of issues. We did come across some of those plugins that we're talking about for things like voice chat, which were pure C++, which we had to kind of then try and wrap and things like that. So again, early days at the time, but yeah, we came across a few issues like that. But yeah, hitting those frame rate requirements for Sony, that was good fun. We got there in the end, but it did take an awful lot of wrangling in the physics system to get there. We were doing like a little real-time strategy type game in VR, 4-player, peer-to-peer as well. So yeah, it's good fun. With the achievements and things like that, yeah, again, we're only targeting one platform at a time, so it isn't too bad. But yeah, it was. We got the game working, running locally. It was all great, and then it's like, now we have to interface with PSN, the store, and all the rest of it as well. So the tooling was fine, and we got there in the end. But yeah, it was good fun, but definitely hit a few gotchas that you described there.
So how early on in development, did you develop primarily for that platform, or was that ported from another platform to that one?
It initially started off for Steam, but then Sony got involved and actually then funded the project exclusively for PSVR initially, with a exclusivity built in, and we could then release on Steam a couple of years later. So yeah, it was started off on Steam, then went to Sony PlayStation VR, and eventually ended up back on Steam.
Fantastic. And so how long did it take you in terms of optimization work to get it to where you wanted it to be?
There's about a year between two of us. There's only two of us on the project. So yeah, it was. Yeah, I was going to say about a year's worth of optimization and work to get there. Once we've kind of got all the SDKs and kits and everything set up. But yeah, Sony were very helpful with supplying all the kit and multiple headsets, multiple kits, because it was a 4-player game. We had to kind of set up 4 TVs and 4 consoles. So yeah, that was great. But it did take quite a bit of effort to get there in the end between two of us.
I run a porting studio and we specialize in this work. And I'd like to add two things, or just enhance two things. One is asset bundles and addressables should have been in red and highlighted and blaring at us, just because, well, a couple of reasons. Obviously, memory usage and runtime on consoles, but also for build times. When you are iterating on a build, doing all this work, and you have to make a full build of your game to install on a console, you can't wait 25 minutes, half an hour, really, and stay in the mindset. You have to do a lot of work in the editor and in Visual Studio, hope it's going to work, and then wait an hour and do something else while you make a build. So when you use addressables and when you do resource asset bundles, that speeds that up no end. So, and addressables in particular do that. And the other thing is, question, are Unity looking at any networking solutions which might ease the pain of cross-platform multiplayer? I know that's a big area for other companies to do as well. Just a general question. If you do multiplayer on consoles, across multiple consoles even, you're looking at several orders of magnitude more complexity than just the work you've explained here.
Yeah, agreed. So to address that point, I mean, yeah, cross-platform multiplayer is a big topic, and we have, when Unity obviously now work with multiplayer, and there's a suite of solutions there, but they're very specific to a certain thing, and we have other products like Matchmaker and others, but it's a big space, right? And if you were to say like, hey, there should be a unified networking layer that works across all of these with all the functions that everybody wants, I think that is a beautiful end state that I would very much like to see. The reality of the situation is that would be another scale of projects that would have that our multiplayer teams would probably need to to look at, and it's not something I'm aware of us looking into right now. I know there's a lot of developments in multiplayer, but I would highly suggest referring to their documentation because I don't specifically know that, I'll be honest. But in terms of your other point about asset bundles, yeah, it's not just you're right, those build times as well. And you can actually, if you're only changing scripts, you've got script-only build, which does help the iteration time. Not everybody is working on small indie games, you're right. Some people are working on games at scale, and build times in the hours is not fun for rapid iteration. Yeah. There's one here.
So I'm not fully sure of which sort of side it is on the Unity side or on the console sort of side, who handles it. But I find the examples of how to use certain APIs or libraries in console development. I started off first doing Switch. I found they had a really nice library of all different examples of controller inputs, multiple controllers, save data, rumbles, everything all in one nice list. But I'm having troubles with PlayStation and with Xbox trying to find nice examples like that, and I'm not sure if you can give better advice or basically pushed onto Xbox or whoever handles those sort of support of consoles and say here's some nice examples to have a library to look at, and you can see the code, how's it used, and a nice small project you can boot up, you can see, edit, change, or work
Yep.
with.
So that's a tricky one to answer because there are multiple responsibilities in play there from either the platform holders or Unity as the middleware provider. Unity, in some cases, provides the plugins that integrate into those APIs. And where possible, we try to provide documentation. You wouldn't be the first person to say a sample project that covers all of this would be really nice, that can look at them. The team that supports the forums, if you post on our forums, is a specific team of support engineers who are there to provide support for console. It's been historically quite difficult to build those and maintain them with constant change and with people wanting to do. Sometimes when we've done them before, they're too generic and they're not specific enough, or they're too specific and they're not generic enough. And it's quite hard to find a balance between what works for the solo indie developer versus what works for the enterprise studio who want to integrate in. So where we've not got those, we generally tend to have documentation to provide those, but it's one of the key considerations that I already have on my plate when it comes to looking at cross-platform APIs, is how do we make this kind of generic enough at the base level to help the solo indie dev, but expandable enough to support somebody who wants to go deep into all the features of that platform. Because not everybody wants every platform feature, right? Some people just want to know achievements, I just want to write my save data and load it, and that's probably enough and handle a user for most people. But some people need to go deep into those APIs, and how much support we provide and how much we document on that generally tends to now be on a case-by-case basis. The forums are there to help you. So if you can't get the answer you need, posting on those forums is great because it goes specifically to our console support team, who will endeavour to answer it for you. But yes, in certain cases, it's also the responsibility of the platform holder as well. I can't go into more details because it's under NDA, I'm sorry. Certain platforms do that, certain don't. And my advice is if there's something missing or if you're finding the process really hard, reach out to your contact to the platform holder because they will be able to advise you on whose responsibility that one is. I can't say in an open forum like this, I'm afraid. Look like everyone's like, let me go. Well, if there's no further questions, I hope that's helpful. But what I will say is here's some resources. There's a pretty simple overview of a lot of the stuff that's been taught that you can get on the Unity website. This ebook, apologies for the ridiculously long URL. If you take a copy of that ebook there we produced recently goes into an incredible amount of detail about profiling and optimization through all the different tools. It's actually an excellent resource for anybody who's making cross-platform games. And if you want to delve into some of these topics a little bit more, there's a Unite Copenhagen talk by one of our console team who went over a lot of this in much more detail. I'd love to have gone into more detail, but I only have 45 minutes. So it's difficult to do in that forum here, but I would highly suggest that middle link and the bottom one as well as further resource on this. I'm available on Twitter there's my thing. If you want to reach out to me directly, talk to me about your experiences in console development, whether they're good, bad, horrific, and you want to tell me that Unity needs to do better, that's fine, that's what I'm here for. I'm keen to hear your experiences, and there is a survey, as I mentioned, which I'm hoping to gather as much data so that we can make sure that we do the right approach to trying to tackle this in the future. So thank you, everybody. I appreciate your time.